Welcome to our channel with new interesting episode. Imagine something incredibly strange happening in our solar system, a mysterious force changing the paths of the planets. Now, picture Jupiter, our biggest planet, on a collision course with the Sun. What would happen if this massive gas giant collided with an even bigger one? How would Jupiter get to the center of our solar system? Would the Sun become more powerful? And how might this be dangerous for us here on Earth? Let's dive into what could happen if the Sun swallowed Jupiter. Before we talk about the massive collision, let's understand how this event could even start. For Jupiter to crash into the Sun, something extraordinary would need to happen to its orbit. This change would likely come from a huge gravitational disturbance. The most probable cause would be a rogue star or a black hole passing dangerously close to our solar system. These objects are enormous, at least a couple of times more massive than our Sun. As these rogue objects move through space, they'd interact with Jupiter's gravitational field. Jupiter is about 318 times more massive than Earth, so its gravitational field is very strong. Whether the rogue star or black hole pulls Jupiter towards it or gives it a lot of kinetic energy, Jupiter's orbit would become very eccentric, or stretched out. But there's a big catch: these rogue objects would need to pass by at the exact right moment to only affect Jupiter. Otherwise, other planets could also be thrown out of their orbits, causing a lot of chaos. After orbiting the Sun at an average distance of 778 million kilometers for billions of years, Jupiter would begin its dive towards our star. But this wouldn't happen overnight. It could take years, decades, or even centuries. Jupiter would travel this vast distance, accelerating faster and faster due to the Sun's immense gravitational pull. This process is called spiraling orbital decay, where Jupiter would orbit in tighter and tighter spirals until it reaches the Sun. As Jupiter gets closer, it would reach a point called the Roche limit, about 900,000 kilometers from the Sun. At this distance, the Sun's gravity would start to tear Jupiter apart. This is because the gravitational pull on the side of Jupiter closer to the Sun would be much stronger than on the far side. Jupiter would become tidally locked, meaning one side would always face the Sun, just like how one side of the Moon always faces Earth. For this to happen before Jupiter starts disintegrating, its rotation speed would need to change dramatically. Currently, Jupiter rotates once every 10 hours, but it would need to slow down a lot. As Jupiter gets even closer, the intense heat and gravitational forces from the Sun would start to tear it apart. The outer layers of the gas giant would begin to strip away, creating massive streams of gas and dust. These materials would form a glowing trail behind Jupiter, making it look like a giant comet. The closer Jupiter gets, the more violent and dramatic this process would become. Once Jupiter crosses the Roche limit, it would start breaking apart entirely. The tidal forces would be so strong that they would overcome Jupiter's gravity, causing it to disintegrate into smaller fragments. These fragments would then spiral into the Sun, creating spectacular explosions as they collide with the Sun's surface. What happens to the Sun when it swallows Jupiter? Would it become bigger and more powerful? The answer is both yes and no. When Jupiter's fragments collide with the Sun, they would release a tremendous amount of energy, temporarily heating up the Sun's outer layers and making it shine more brightly. However, this effect would be short-lived. Since Jupiter's mass is only about 1,000th of the Sun's mass, the overall impact on the Sun's size and power would be minimal. The real concern is the effect this event would have on Earth. As Jupiter gets closer to the Sun and starts to break apart, the gravitational dynamics of the entire solar system would change. The other planets, including Earth, would experience shifts in their orbits. These changes could lead to more frequent and intense meteor showers, increased volcanic activity, and even shifts in climate patterns. Moreover, the debris from Jupiter's destruction could pose a direct threat to Earth. Some fragments could be flung outward, potentially crossing Earth's path and creating devastating impacts. Even if Earth avoids direct collisions, the increased amount of space debris would pose a significant risk to satellites and space missions. While the Sun swallowing Jupiter might not make the Sun significantly bigger or more powerful, the event would have profound effects on the solar system and Earth. The gravitational disturbance required to set this event in motion would itself be a cataclysmic occurrence, likely involving a rogue star or black hole. The destruction of Jupiter would be a dramatic and violent process, creating spectacular visual effects and potentially endangering Earth with debris and altered gravitational dynamics. This scenario reminds us of the delicate balance that maintains the harmony of our solar system and how easily it can be disrupted by extraordinary cosmic events. In conclusion, while the idea of the Sun swallowing Jupiter seems like something out of a sci-fi movie, it's a fascinating way to explore the powerful forces at play in our universe. It shows us how interconnected everything in our solar system is and how a single event can have ripple effects that change everything. In a thought experiment of cosmic proportions, imagine a scenario where Jupiter, the largest planet in our solar system, is thrown off course by a powerful gravitational disturbance and begins its journey towards the Sun. This hypothetical event would require a colossal disruption, possibly caused by the close passage of a rogue star or a massive black hole near our solar system. These astronomical giants, several times more massive than our Sun, could exert forces capable of drastically altering Jupiter's orbit, setting it on a collision course towards the center of our solar system. Jupiter, with its immense mass, 318 times greater than Earth, would not immediately plummet into the Sun. Instead, it would embark on a slow and spiraling descent, driven by the gravitational pull of our star. This process, known as spiraling orbital decay, could unfold over a span of years, decades, or even centuries. Despite its colossal size, Jupiter's movement towards the Sun would be gradual due to the vast distances involved and the intricacies of orbital mechanics. As Jupiter draws nearer to the Sun, it would face a critical point called the Roche limit, approximately 900,000 kilometers from the Sun's surface. At this proximity, the Sun's tidal forces would begin to exceed Jupiter's gravitational cohesion, leading to its eventual disintegration. This phenomenon would stretch Jupiter into a distorted, elongated shape as its atmosphere is stripped away, forming a luminous ring of dust and gas known as an accretion disk around the Sun. The absorption of Jupiter by the Sun would temporarily increase its brightness, causing a slight enhancement in solar energy output. However, due to Jupiter's relatively small mass compared to the Sun, only about 0.1%, the overall impact on the Sun's luminosity and energy emission would be minimal and short-lived. Observers on Earth might notice a slightly brighter day sky and enhanced visibility of the night sky during Jupiter's final approach towards the Sun. Beyond the astronomical spectacle, the absence of Jupiter in our solar system would have profound implications for Earth's safety. For billions of years, Jupiter has acted as a cosmic shield, gravitationally deflecting or absorbing potentially hazardous comets and asteroids that might otherwise collide with our planet. Without Jupiter's protective influence, Earth would be significantly more vulnerable to these celestial impacts, increasing the likelihood of catastrophic events that could threaten life on our planet. While the scenario of Jupiter colliding with the Sun remains purely theoretical and highly unlikely in reality, it serves as a reminder of the complex dynamics governing our solar system's stability. The hypothetical event underscores the delicate balance of gravitational forces and the profound interconnectedness of celestial bodies within our cosmic neighborhood. In conclusion, whether contemplating the hypothetical collision of planets or the intricate workings of celestial defense mechanisms, such scenarios provoke awe and curiosity about the vastness and unpredictability of our universe. They challenge our understanding of cosmic dynamics while highlighting the ongoing quest to unravel the mysteries of space and safeguard our existence in this vast and ever-evolving cosmos. Thanks for watching. Keep watching and stay tuned. Have a good day.